Hello everyone. So today we are going to record a video for my Introduction to Programming course, and we're going to talk all about functions in Python. So what we've done in the course so far is talk about constructs, different constructs in programming. We talked about if statements, loops, for loops, while loops. What we haven't really talked about is how we kind of organize our code. So what functions are, they are reusable blocks of code that we can perform a specific task with. So for example, we've been using a print function to print things onto a screen. We've been using a lower function to be able to convert a uppercase or all the uppercase letters into lowercase of a string. We've used split, we've used strip, we've used all of these functions that perform a specific task, but these are all written for us. So what we want to do in this tutorial is to be able to write our own functions to be able to perform our specific tasks. So the reason for doing this is to be able to organize our code a little bit better, to be able to maintain it and to be able to test it a little bit better. Because if we write a function and we test it and we're clear that it works, then we don't ever have to touch it again. Right? So another reason for writing functions is to be able to delegate work. So for example, if we're working on a team of 3, then each of us can write a function and then we won't be able to kind of step on each other's toes, and we're going to be able to merge our functions together into one program a lot easier. So we're going to be able to see that in a little bit. So let's dive in. So here we have our code. Let's start creating a file, and I'm just going to save this very quickly. Let's just call it add.py. And in add.py, I'm just going to sum two numbers together. Now, obviously, everybody knows how to do this. So I'm just going to make two variables. So we'll say x equals 5 and then y equals 10. And then we're going to sum these two numbers together. So we are going to do a result is equal to x plus y. And then we're going to print out the result. Okay, so I hope everyone understands what this program is doing. So basically, what I want to do is to be able to split up the work here. So you notice that individually, we have two, I guess, semantic parts to this program. So we have the parts that are assigning the variables. We have the part that is doing the adding, turning the addition into a result, and then also printing it out. So what I want to do is write a function for this part of the program. So what we do when we create a function is we use the command def. So def is we're defining a function, and the function header includes two things. Number one, it includes the name of your function. So you can call this whatever you want as long as it's not a keyword in Python. So for example, I can say add xy. So here's the second thing that we need to include, which is what are the inputs that you'll need for this function. So just like print, we need to give it some inputs. Split, we need to give it some inputs. Strip, we need to give it some inputs, and so forth. So think about all the functions we've been using in the course. We have to give it some inputs in order to do what it needs to do. So we need to supply it with an x and a y. In fact, what we'll do is change this into a and b, and I'm going to show you something in a second. And what I'm going to take with a and b is whenever you call this add function, I'm going to take the result and do a plus b, and then I'm going to return the result. Sorry, not return. I'm going to print the result. Okay, so you notice what I've done is I've taken these two parts and I've just simply put it into the function, right? So the function really just behaves exactly as what we want to do. So in place of this, I can simply call add and it will just do whatever I want to do. Now, the thing is that when we invoke add, when we're calling the function add, we have to say, what are the inputs for add, right? So just as always, we have to supply the inputs. So in this case, we'll say it's x and y, right? We're going to supply these two inputs and we're going to run this. And you're going to see that it's going to behave very similarly to our program. All right, so you see that it prints out 15 in this case, which is what we expected to do, right? So that's really how we create a function. So in general, what functions are for is really just for for readability and for code reuse. So if there's many cases or there's many situations in which I have to add two numbers, I'll probably want to define this function and then just simply call it over and over again. Now, this is a very simple example. We would never really write a function called add because add is pretty simple. It's only one line, right? So once we get into a little bit more advanced stuff, then this will hopefully make a lot more sense. Now, the last thing we'll do here is typically when we organize our programs, there will be a function that is called the main function. So a main function is usually called for just running it as a default. So this is where we actually start our execution of our program. So I'm going to define another function, and notice that all of my functions are defined at the beginning of my my file. So this is the typical convention, and the typical convention is to call your main function main. Okay, you don't have to, but this is just a good convention to have. All right, so then we're going to create another function in which we put all of this inside of that main function. So I'm just going to indent this, and basically this is what the main function does. It assigns x and y, and then it calls add xy. So if we follow the execution, you can see that it assigns, and then it calls, and then the x and y, whatever the value of x and y is going to be copied to A and B respectively, and then it'll perform its action in here. Okay, so again, we haven't done anything to the logic of the program. All we've done is make it read a little bit better, right? So in essence, we are doing exactly the same thing. Now, the last thing we need to do is, you see that we've defined two functions. By default, if we run it right now, it won't do anything, right? It won't give us any result. And that's because we haven't supplied a starting point. So typically in this type of scenario, we would call the main function, right? So call the main function. And why are we doing that? Because we want to say this is where you start, right? So you start with assigning the variables, and then you add, and then whatever you have to do next. So I just want to show you very quickly that the sequence of this execution is that we call main, and then the next step is we're going to assign x to be 5, and then we're going to assign y to be 10, and then we're going to call the add function, right? In which case we're going to jump all the way here, and we're going to take the result, and we're going to add a and b together, right? A and b, of course, being supplied by x and y. We're going to print it out, and then as soon as this is done, notice that this is the end of the block. It'll jump back down here, right? And then it'll execute whatever is coming next. So for example, if I had another print statement here, right, then we will execute that print statement after the print result. Okay, so I hope you can see the execution is like that. We execute the function until the very end, and then we jump out of it. Jump out of it, and then that's it. So notice that after main is done, it'll come back to where main was called, and then the next step will just be the end of the program. So if we run this, hopefully you can see that we print out 15, right, as a result of a plus b, and then after this is done, it comes back to this location, and then it prints done. And then after that, it jumps back to this location, and then we're done. Right? The program just finishes. Okay, so hopefully that makes sense. And so I just want to explain these variables for 1 second. So one of the things that we have to be very careful of when we're creating functions is we have to worry about this thing called scope. So a scope of a function is really talking about where the variables exist, right? So where do the variables exist? So what do I mean by this? So if we follow the execution of this program, at the very beginning, you'll notice that the program just starts with nothing, right? So as soon as we call main, what happens is that there's going to be a block of memory that is put on this thing called a stack. So on the stack is going to be everything associated with main. Okay, so we've called the main function, and now we're going to have to kind of give it some variables. So within the main scope, within the execution of main, we have two variables. We have x and y. So we've defined x, right? And we've given it the value of 5, and then we have y, and we've given it the value of 10. So these two variables only exist while main is being executed. So once again, x and y only exist when main is being executed. So in this scenario, up till this point, up till we call add, x and y exist. As soon as we call add, what happens is that Python is going to add another stack on top of this, and now we are in the scope of add. So as we're executing these commands, we have a variable called a, which is now 5, right? Because you see x has been put into a, and then we're going to have a variable called b, which is equal to 10 because we've put y in there. And as we're executing add, x and y do not exist. Okay, so if I try to print x here, it'll give me an error. Okay, so after add gets executed, this thing now disappears. Okay, so let's say add is finished, right? We've printed out 15, and now add disappears, and now we're back into the scope of main. Okay, so I hope you follow that execution. And once again, if I'm back in the scope of main and I try to, instead of print done, let's say I try to print a, that's going to give me an error because a no longer exists. Okay, so when we create functions, we have to understand the scope. We have to understand that the variables that we create only exist within that function, only within the execution of that function. All right, so we'll talk about this a little bit more next class. But for now, let's move on to another example. So this might be kind of a stupid example because it really is not necessary to create a function called add, but let's do something a little bit more complicated with a little bit more semantics. So I'm going to create a new file here. We'll save this file as, let's call it multi.py. And here we want to print out a multiplication table. Okay, so there are certain jobs that we want to delegate for functions. There are certain jobs that we want to delegate for main, and then oftentimes we want to write several functions in which the main will just call those functions back to back, right? So it'll call it one by one. So we'll do another example of that a little bit later, but for now, let's just do another one as an exercise. We will write a program to, let's say, print out a n by m multiplication table. Okay, so whatever it is, like just some n by m multiplication table. So 1 times 1, 1 times 2, 1 times 3, and then on the rows we have 2 times 1, 2 times 2, 2 times 3, and so on, right? Okay, so what we want to do is now here I want to show you how we can kind of delegate our work. So let's say that we have 2 people working on this project. Okay, so one of us is going to write the main function. Okay, so what does the main function do? The main function is going to maybe gather some information or gather the inputs from the user. So I'm going to say rows is equal to int, and then I'm going to say input, and then ask the user how many rows. So enter rows, right? So how many rows in your multiplication table? And then similarly, I'm going to ask for the columns for the multiplication table. So we'll say enter columns. And so the user is meant to enter the number of rows and the number of columns in this multiplication table. And then let's say that I'm going to delegate this work to somebody else. So I'm going to tell my friend, why don't you write a function called print table? And I'm going to supply you with 2 inputs. I'm going to supply you with the rows and the columns. And now it's your job to make sure that this works, right? So at the same time, in parallel, my friend could be writing another function, right? So my friend could be writing the print table, right? And now we've already agreed that this print table function is going to require rows and columns, right? So those are my inputs. Now notice I did use the same variables, but they do not have to be the same. Just like in our last example, I use different names for the variables. As long as the number of variables match and the places of those variables match, that's all you need. All right, so how am I going to print out this this table? So the first thing we'll do is we'll go through that for loop, right? So if you remember our discussion on nested for loops, we're going to need a nested for loop here. The slower loop is always the outside. So the slower loop in this case is going to be the rows. I'm going to do for r in range. I'm going to go from 1 all the way up to rows plus 1. Okay, so if you remember why it's rows plus 1, because we want all the numbers from 1 all the way up to rows, including rows, right? So we need to do a plus 1. In the slower loop, we're going to do the for columns. So for C in range, and then I'm going to do again 1 up to columns plus 1. And this is going to handle the columns. And so I'm simply going to print out here the, well, I'll turn it into a string. It's not necessary in this case, but I'm going to multiply C by R and turn that into a string and print it out. And I am going to end this with a space. Okay, so if you remember what space does, it basically, or sorry, what end does, it basically replaces an end of line. So print usually gives you an end of line, but here I actually want it to be a blank, just a space. And then finally, after every loop, I want to have an end of line character. Okay, so I actually do want to print. So this blank print is just to give me an end of line character. Okay, so again, I just want you to follow this code and just verify that what we're doing is we're printing out a multiplication table that goes number of rows. So let's say rows is 5, it will go 5 rows, right? And every time we print out all of the columns, and then after we print out all of the columns, we end of line. We do an end of line. So we go to the next line after that. Okay, so let's test this out. And as always, we've printed out these functions, or sorry, we've defined these functions. The next thing we need to do is actually call the main function. All right, so we'll save it and we'll run it, and it'll say enter rows. So let's say I enter, I don't know, 5 rows, and then let's say 6 columns. Okay, so I want a 5 by 6 multiplication table, and that looks pretty good. So 1 times 1, 1 times 2, 1 times 3, all the way up to 1 times 6, and then we have 2 times 1, 2 times 2, 2 times 3, all the way up to 5 times 6. So this is a 5 by 6 multiplication table. All right, so that's basically what this does. Now notice that we could have written this all in one file, but defining the different functions and defining the different usages for each part of the code allows us to be able to test out this code. So for example, what do I mean by this? Now, let's say at this point, I'm not really ready to kind of put it into the main program. I actually just want to test out my print table, right? In fact, I'm not very happy with this printout, right? So what I want to do is I actually want to have the spaces aligned. I want this table to align properly. So I'll show you kind of a command for that. So the first thing we'll do is I'm going to take a look at what the max number is. Okay, the max num is always going to be the rows times the columns, right? Because if you look at this, our rows is 5 and our columns is 6. Our max number is always going to be rows times columns. It's always, well, in this case, it's 30, right? So I'm going to take a look at the max column, and I'm going to figure out how many digits it has, right? So the number of digits is going to be the length. We'll call it like the length of max num. Okay, the length of max num is going to be the length when I turn the string, when I turn this into a string of the max num. All right, so now I have basically the length of the string that is associated with the max num, right? So the reason for doing this is I want to see how many spaces I need to account for to adjust all of these numbers so that they align properly vertically, right? So right now it doesn't look very good as a table, right? Now the last thing I want to do is I want to come down here. When I do a print, there is a command called rjust. Okay, so what this means, what rjust means is it's a right justified. So I'm going to push my values all the way to the right hand side, right? I'm going to push it all the way to the right hand side, and I want to leave room for the length of the max num. Okay, so basically what this means is when I print out this string, I want to leave this much room. So even if it was a 1-digit number, I want this much room to print out this number. And in addition to that, I want to right justify it. Okay, so there's actually simpler ways to do this with formatting, and I'll leave that as an exercise for you. But this is basically, one of the ways that we can do it. So I'm going to save this, and instead of running it, let's pretend I am this friend who is only working on print table. So my only responsibility is to make print table work. So what I'll do is save this and then I will run this. Okay, so notice that I have not called main. So when I run this, nothing happens. But in order for me to test my own function, what I can do is do a print table. Right, so I'm going to call this function, and instead I'm just going to pipe in the number of rows and number of columns. So for example, if I type in 10 and 11, right? So I'm just basically testing to see if this function works under this scenario, 10 and 11, right? So it's up to my friend to make sure the main function works, but it's up to me to make sure the print table works, right? So I'm going to test this a couple times, and I'm going to make this a little bit bigger. And I'm pretty happy with this because you see everything aligns properly, right? So everything aligns like this, and everything looks like it's vertically aligned. So great. I might want to do one more just to make sure that, you know, everything is working properly. So what if I have 10, 9, right? Or better yet, 8, 9. Let's test that out to see if that works. And again, you see that all of the columns do align properly. So I might try that for a few more values. This is the testing phase, right, that I'm going through. And now I'm done. I can tell my friend I'm done with the function. Let's merge everything together and let's see if it works. Right? So at that stage, my friend would say, okay, I'm done with main. I've tested it also. And so we're just going to call main and let's see if this works. So altogether, our program is going to look like this. It's going to ask for the number of rows, it's going to ask for the number of columns, and it's going to print out the multiplication table. So I hope you can start to see what the purpose of having functions are, right? So it's actually quite useful to be able to write functions and to be able to kind of work together with more than one person. It's also a good idea to use functions for testing, right? So as I was saying, if I test the print table and it works, then I don't really need to do anything else, right? I don't need to come back to it every time, right? So if something goes wrong, then I know it's not in the print table function, right? It must be somewhere else, right? So it's good for debugging and stuff like that. Okay, so the next thing we'll do is let's come back to Turtle. So Turtle is something that we worked with in the past. So let's do another Turtle program. And this time, let's take a look at how functions would help while we're kind of reusing code. So the very first example, we really haven't shown examples of code reuse, right? So what's the purpose of writing functions if we're going to use it only one time, right? So instead, what we'll do here is we'll write a function, or sorry, we'll write a program that imports Turtle, and we'll also import random. All right, so I'm going to use this Turtle module in order to draw onto the screen, but I'm also going to write a function to draw a building for me, right? I guess a little house for me, and then I want to over and over again draw these houses, right? So I want to draw houses over and over again, meaning that I'm going to use the same code, but I'm going to call it over and over again. So this doesn't require me to be able to, you know, rewrite the code over and over again. All right, so the first thing we'll do is we will define a function called draw building. Okay, and for draw building, I'm going to define xy. So xy is going to tell me where on the window are we going to draw this building. Okay, so I'm going to supply it with an x and y coordinate, and then I'm also going to supply it with a width and a height. All right, so supplying it with a width and a height and these coordinates will be able to, I'll be able to tell it these four things, and it will be able to go to one particular location and draw this building. Okay, so we'll just make it a simple looking building. The first thing we'll do is we'll do a turtle.penUp. Okay, so we'll do the pen up, and then we'll make the turtle travel to XY. So the command go to XY is going to allow me to jump there. And then we'll do a turtle.pen down. Okay, so pen down is going to put the turtle's pen down, and then we'll draw the building. Okay, so this is, so we'll draw building here. This is really just a house, I guess. So the first thing we'll do is let's supply some building colors. Okay, so this is the building colors that we'll choose from, and we'll just randomly type up a few things. Okay, so then we'll do a turtle dot fill color, and I'm just going to randomly choose one of these. So building colors. All right, so hopefully that makes sense. I want to fill whatever the building is with that color, and then I'm going to do a begin fill. So turtle dot begin fill, and then let's do a for loop that creates a kind of a rectangle with the width and the height. So we'll do a for. Now, I'm not going to need a variable for this, so we'll do a for blank in range 2. And we're going to create the turtle. So we're going to do turtle dot forward. And we're going to first do the forward of the width. And then we're going to do turtle dot right. So we're going to turn 90 degrees. We're going to do turtle dot forward, the height this time. And then we're going to do turtle dot right again, 90 degrees. And then after all of this, so if we do this 2 times, hopefully we'll get a nice rectangle. And then we'll do the end fill. So turtle dot end fill. And that is going to give us the actual building part. Okay, so the next thing is we'll draw the roof. Okay, so the roof, we'll make a little triangle for this. And again, we'll just do some roof colors. Okay, and then we'll do the same thing, turtle dot fill color, and then we're going to do a random dot choice of the roof colors. Okay, so I hope you're following what I mean by this. We're going to do the same thing as we did before, turtle dot begin fill. And then we won't do a for loop here, but I will simply do a go to. So we'll do a turtle dot go to. And we're going to go to x plus the width. Sorry, width divided by 2. Okay, so whatever our x coordinate is, I'll take half of the width, and then I will also take y plus half of the height. Okay, so I hope you understand what I'm trying to do here. Basically taking, so if this is my width, I want to take half of the width and then also half of the height, right? So to kind of make a triangle. So I want to go to there, and then I want to do another go to. So turtle dot go to, and this time I want the x plus the width, so the whole width, and then also the y as well. So the y, I want to go up, and then I want to come back down, right? So basically that's what I'm doing there. And then I'll finally return to the original location that I was at. So go to xy. All right, and then we'll do a turtle dot end fill. I hope this works. Okay, we'll test it in a second to make sure that this actually works. All right, so in fact, I think we should test it right now. Once we finish writing a function, it's always a good idea to go back and just take a look and see if it works, right? So we'll call this draw.py. And remember what we said before, if I want to test it, I'm going to run, and then I'm just going to call this function. So I'm going to do draw building. And let's apply it with some x and y. So let's say I want to go to 100, 100, and I want a width of, let's say 50, and I want a height of 70. All right, so let's take a look if this is working. This is not working. In fact, I spelled begin fill wrong, and begin fill should have an underscore, and end fill should have an underscore, and so I should do those. So this is good because we're kind of running into our debugging mode here, right? So I'm going to run this again. So notice that if this is my task, then it's pretty simple. I just want to make sure that this part works, right? All right, so we'll call this again. See if it works now. Okay, I'm pretty happy with that. So there's my little building. All right, so let's say at this stage that I'm going to have another friend, and my friend is going to know about draw building. Okay, so he or she knows that I'm going to write a function that creates a building. So what my friend wants to do is draw a whole town, right? So they're going to define a function called draw town, in which they're going to be supplied with the number of buildings. Okay, so let's say let's say my town has 10 buildings. Then I'm going to call draw town. I'm going to supply 10 as an input for num buildings. Okay, so let's do that. Okay, so now notice that when my friend does this function, they will know about draw building as a function, so they can use it just as just as is, because they'll trust that I'm going to produce that function for them. All right, so we're going to do draw town. So we'll first do our turtle dot speed to be 0. I actually want it to just go really fast here. I want my turtle to hide. So I believe it's called hide turtle. So we'll do hide turtle, and then we'll do a for blank in range, and then we want to do the num buildings, right? So we want to go through all of these buildings, and one by one we want to draw these buildings. So I'm going to do a random x and a random y, so hopefully you remember how to do this. We're going to do a random dot rand int, and let's just pick a number between -400 and 400, and then same with y. So I'm going to pick two random numbers, x and y, that are between -400 and 400. And then I'm going to supply a width. Let's say the width is also random. So we'll do random rand int. And let's see, our width is going to be between 20 and 60, let's say. And our height, again, we'll do a random dot rand int. And it's going to be between 50 and 80. All right, I think those are good numbers. And then we will call draw building. You see, the person who's writing this function doesn't even care how draw building works, doesn't even care how it's programmed or anything. It just trusts that it works, right? So we're just going to pass in the x, the y, the width, and the height in that order, right? And it's going to do this however many times, num building amount of times. All right, so I'm going to do one more thing here, which is hide the turtle. Sorry, not hide the turtle. I wanted to do turtle.done, because I don't want the window to close on me. All right, so let me close this up. And let's run this. I realized that my window was just off the screen, so I hope you were able to see the earlier one, but if not, I will drag this window back. So at this stage, I will run this program. And now I'm going to draw town. Now I'm going to test draw town. Okay, so just in here, I'm going to do draw town, and then let's just do 10 buildings, and let's see if it randomly gives me 10 buildings. All right, so there is our program. I hope you can see that. Some of this is off the screen, but hopefully if you're following along, you can see that it randomly gives me 10 buildings somewhere here, right? And these buildings are randomly width and randomly heighted. Those are English words. Okay, so the last thing might be, well, let's do a main program. Now, the use of the main program is usually to be like a maestro. It kind of just directs where our code is supposed to go, right? So in our main, what do we need in order for this thing to run? Well, maybe I need an input from the user, right? So I'll just do input, and then we'll say input, and we'll ask the user, enter num buildings. Probably want to be a little bit more explanatory than that, but at this stage we'll just do the turtle.title. This will give us a nice little title on the window, my town maybe. All right, we'll call this my town, and then we will then call draw town with the input. All right, then after that we'll do a turtle.done. Okay, just to make sure that the turtle doesn't go away, or the screen doesn't go away, and I'm going to call main. All right, so let's follow the execution here. So the first thing we're going to do is execute main, right? So we're going to jump into the scope of main. Remember our diagram, right? So we're going to get an input from the user, and then we're going to enable this turtle's title called my town, and then we're going to call draw town. right? So we're going to call this function with the number, whatever the input is from the user. And then we're going to do all of that, right? So the thing that we just saw execute from before, right? It'll give us all the towns, hopefully. And the draw towns is repeatedly going to call draw building, right? So it's just going to keep calling it. And every time draw building gets called, it will go and draw building, right? And then hopefully by the end of this, we'll finish the main function and we'll have our town, right? So that's basically what functions are for. Now, if you take a look at this program, clearly it reads a lot better, right? So for readability reasons, you can see that, oh, what am I doing at this stage? I'm doing a draw building, right? Instead of a block of code, which I probably don't know what's happening there, right? So I would call these functions specific names that make sense to me. And this is basically how we become a better programmer. All right, so let's run this. So it'll say enter the number of buildings, let's say 20, and then it will give us something like this. Hopefully you can see this, right? So it's going to give us 20 buildings. It just kind of randomly puts it onto the screen. And yeah, and that's basically one application of a function. All right, so I want to talk about one other thing very quickly, and then we will be ready for the next phase of what we're talking about. So the next thing I want to talk about is, notice that all of these functions just have a specific purpose. It does what it needs to do, and then it ends, right? So for example, what does draw building do? Well, it just draws a building and then it ends, right? So if you think about the functions that we've been using so far, like print, like strip, like split, right? What we actually get is something in return, right? So we get something in return. So for example, when we do like hello, comma, world, world, and then we do split on this, right? We split on the comma, right? So notice that when we call a function, we have a we have an input that we need to give it, right? So what we're supplied with is actually a list, right? So if I just call this LST, right? If I take a look at LST, it gives me something in return. None of the functions that we've been writing so far gave me anything in return, right? So notice that like in the other function that we wrote, print table, all it does is it prints out the table, right? It doesn't give me back anything for me to then work with later on. So the last thing I want to talk about here is a value returning function. Okay, so a value returning function is for basically exactly as it sounds. I'm going to return for you a value, right? So let's go back to our to our add program. Now notice here that the purpose of add is simply to print out the result, right? But that's kind of useless, right? Because what if I want to add this, but then I want to apply something else to it, right? So I want to like maybe multiply it by 5 afterwards, right? So then I wouldn't be able to do it because all this does is it prints out the result. The result is gone, right? So once we add 5 and 10, it's gone. So instead of print, I'm going to replace the print with a keyword called return. And what return does is it says, okay, I'm going to run what I need to run here, but I'm going to take whatever the value is as result, and I'm going to give it back to the caller. Okay, I'm going to give it back to the caller. So notice when I call the function add, I just called it. I just said add xy. But this time when I have a return, I'm going to assign it to some variable. Let's call it r. Okay, so the variable r is going to be given whatever value is returned from add. Okay, so add's going to do what it needs to do, and then whatever's in the return, that value gets plugged into r. Okay, so again, let's follow the execution. We have x is equal to 5, y is equal to 10. Then it jumps over to add, right? It adds the result, so now result is 15, and then 15 will be returned, and basically you can say that is going to be replaced by 15, right? So 15 will be given to r, right? So this is just an example of a number, right? So the good thing about this is now we can do something else with r, right? We can multiply it by 2, or we can do something else in a different calculation. We can give it to another function, and that's the purpose of value returning functions. So if we run this, hopefully you can follow the execution and you can see where we're getting the number 30. Right? So we have the 15 and then we're multiplying it by 2, right? We're actually using the value for some other purpose. All right, so to illustrate this, let's write another program very quickly. And here I want to talk about a construct that we're going to use in the future. So right now I'm just going to introduce this construct. I'm going to go into a lot more detail in a future class about this. So I'm going to create this program called cost calculator. So this is, I guess, like maybe a program to calculate the order. Like let's say you're at a restaurant and you're ordering something and it's going to calculate a cost for you, something along those lines. All right, so the first thing we'll do is, so this is a order program. Okay, so food order program, I guess. Okay, so this is going to be our food order program. So the first thing we'll do is I'm going to define this thing called a dictionary. All right, so dictionary is something that we're going to talk about a little bit later in more detail, but I'm going to create a variable called cost dictionary. So what dictionaries are good for is that they will not only allow us to be able to index numbers, right? So notice that when we've been using lists, we index by indexing 0, 1, 2, 3 as a sequence, right? So a list has a sequence, but a dictionary doesn't have a sequence. All it has is a bunch of keys and values. Okay, keys and values. So here's what I mean by this. So the first key in my dictionary is called burger. Okay, so burger, I'm going to give it the value 5. So you could probably guess intuitively what this is talking about, right? So a burger is $5, right? So let's pretend fries is $2. And let's do one more. Maybe a drink, some kind of drink is $1.50. Okay, so you see what we are doing? We have commas, so very similar to a list, but the commas now separate these key and value pairs, which are themselves separated by colons, right? So colon separates the key and the value. So our key would be burger and our value would be 5. Now, the good thing about this is that if I ever want to find out what is the cost of a burger, well, I can index the burger and it will give me the value 5. Okay, so I'll show you what this looks like in 1 second. But let's write a few functions. Okay, so our first function is let's call it get order. Okay, so the purpose of this function is to be able to get the order from the user. And what we're going to do is we're going to keep asking for the user's order, like what food do you want, until they do done, or maybe they just hit enter. Okay, so let's write that. So I'm going to define this function called get order. And get order doesn't actually require any input, so we'll just do it like this. And we're going to have an order list. Okay, so we're going to keep track of the list of orders that this user is going to enter. So I'm going to say item, okay, is equal to, and I'm going to give them a prompt, food. All right, so I'm just going to pretend that they know that this is burger, fries, and drink. I'm leaving a lot of error checks out. I'll leave that as an exercise for you. But if the item is equal to empty, right? So if the item is equal to empty, meaning they've entered just an enter, then I am going to, actually, before we do that, let's put this into a while loop. So we'll do while true. Okay, so while true, meaning this thing is going to keep going. So if the item is equal to empty, then I'm going to just break out of this loop. Okay, so I'm going to break out of this while loop. Okay, but otherwise, if the item is in the cost dictionary. All right, so notice this usage of in, right? So item here is actually referring to the keys. Okay, so if they type in burger, then the item is in the cost dictionary. So this would be true. If they type in, I don't know, sushi, then it would not be in the cost dictionary. Okay, so if it's in, if the item is in the cost dictionary, then I indeed want to append this to the order. So I want to order.append the item. So I hope you understand what I'm doing here. I'm putting all their orders in a list one by one, right? And then else So in the case that it's not in the cost dictionary, I will do, maybe give them an error message. I'll say, sorry, we don't have that. Okay, so we'll do something like that. And when it breaks out of the while loop, presumably our order list is going to be full of the user's order, right? So we're going to simply return the order. All right, so notice here, we're actually returning a list, right? So we can, last example, we showed that we're returning a value like a number, but we can also return a construct like a list, okay, or other things. So we can return many things, right? So our function can actually, return whatever we want. Okay, so let's say that after I get the order, that I will have another function which is used to calculate the order. Okay, so the purpose of this is to calculate the, well, maybe we'll call it calculate total of the order, okay, just so that we don't confuse ourselves. And then I will start with the total being equal to 0. And then I will do for item in the order. Now notice that I'm going to assume that somebody is going to give me a list of order, right? So the person who's writing this function, right, doesn't know where that's coming from, right? They don't even care where it's coming from. All they know is whoever is invoking this function is going to give me a list, okay? So assuming that I have a list, let's just add it up, right? So I'm going to take this and I'm going to do total plus equals, and I'm going to take my cost dictionary, and here is what I want to show you. So the cost dictionary, remember in a list, we usually index it by using this square bracket, right? So if I do, in a list, if I do 0 or if I do 1, I will get a particular value associated with the sequence. But here, a dictionary doesn't have a sequence. All it has is these words, right, that are keys for the dictionary. So if I say item, okay, so notice what we're doing. So let's say the first item is a burger, right? It will say cost dictionary. So essentially what it's doing is cost dictionary burger. And what this is going to give me is it's going to give me the cost of the burger. It's going to give me the value associated with the burger, right? So this is actually a really powerful tool. A lot of the applications that you see, especially online applications or web applications, are heavily dependent on dictionaries. So we're going to look up the dictionary for item, right? So burger is 5, fries is 2, whatever, right? And we're just going to add that to the total. Okay, so I hope you can follow the logic there. And now, maybe after I take the total, make my life a little bit harder here. I'm going to pretend that there's another function that somebody is writing called calculate tax, right? So I'm going to say tax is going to be equal to, and in order to calculate the tax, we're going to need to give it the total, and we're going to need to give it, let's say, a tax rate. So let's say the tax rate is 0.07%. Okay, so 0.07% is the tax rate. And so what we're going to do afterwards is we're going to take the total plus equals the tax. So later, we're going to write this function. We haven't written this function yet, right? But we're going to write this function very soon. And we're going to be able to call this function. And this function will automatically return what the tax will be. So I add the tax to my total. And then finally, I will return the total. You see how this is going? This can go in many different levels, right? And that's what we want to do. Like in programming, we do want to have these breakdowns of logic so that it makes our lives a lot easier. Okay, well, while we're here, let's do our calculate tax. Okay, so we'll do our calculate tax. And for a tax, I'm going to have a total and I'm going to have a tax rate. All right, so for my calculate tax, this is actually quite simple. We're going to take the total, and then we're just going to multiply by the tax rate. Okay, and we're going to return that. So this is kind of a stupid function, but I just want you to see how functions can go many levels in a more complex world. All right, so we have all of those things. And so the last thing we'll do is maybe we will write a main function for this. And our main function is simply going to print out, I don't know, welcome to OrderBot. And so here, let's get our order. Okay, so now what does our order, what does our get order do? So I'm gonna call get order. Okay, but what does get order give me? Okay, get order is gonna give me the list of the ordered items. Okay, so maybe I'll call these ordered items. Okay, I want to make my life a little bit easier. I want to say exactly what this is, right? So ordered items. And now I'm going to let this function run, right? And by the end of this function, I'm going to be able to collect all of the ordered items, right? So what's next? Well, our main is going to be the maestro, right? So it's going to redirect our logic. So then it's going to calculate the total. So it's going to be total cost is equal to, and then I'm going to calculate the total. Calculate the total. And what do I need to give calculate total? I need to give it a list of ordered. So ordered items. All right, so I hope you can see the logic here, right? So I grab the ordered items from get order, and then I immediately send it in to calculate total, right? Okay, so now what do we get? We get a number, right? We get this, I don't know, final cost for our order. And then let's see, well, let's just print it out. So I'm just going to print out our formatted string, your order, and then we'll just print out the ordered items. So that's going to print out the list. Okay, and then finally I will print out the cost. Okay, your cost, and then I'm going to print out the total cost, right? So the variable total cost, and then I'm going to format it to 2 decimal places. And that's about it. All right, so again, let's follow the logic. We're going to call main. Main is going to do all of this stuff. So first it's going to print out welcome to orderbot, and then it's going to get the order, right? So getting the order, it's going to invoke this function right here, and we're going to create an order, and we're going to append all of the items that the user inputs. Now I can see that I think there's a problem here. I really haven't asked the user to enter another food. So let's see here. Maybe this should be inside. All right, so this doesn't repeat. All right, so maybe this will be better. So I'm going to keep asking them for the food, right? And each time I'm going to append the item into the order. And then finally, while we break out of this while loop, I'm going to send back the order to whoever called it, right? So whoever called it is here. So I'm going to give the list back to ordered items. Ordered items is going to be used to calculate the total. And then I'm just going to print out those two things. All right, so I hope you can kind of follow the logic. I'm going to save this as order.py. All right, and then we're going to run this application, and I'm going to make sure that we don't have any mistakes here. What happened? Oh, yeah. Okay, so we have this. And all right, so it's going to ask us for food. Let's say we're going to do burger, fries, and burger again. All right, and then we're going to hit enter, and we're going to fix our mistakes. So calculate tax. Spell calculate tax wrong. Okay, so calculate tax. Okay, let's try this one more time. So burger, fries. Maybe sorry, we don't have that. Okay, and then burger, and then we'll hit enter, and we just need to double check that that is the cost of the burger, fries, and burger. But yeah, that's basically the idea. Hopefully I haven't made any logical errors here, but just to show you that this is how we can kind of break our program into different parts. So at a later stage, we'll actually do a more concrete example of how we would break down a program into functions. And you might be asking, like, how do I know which functions to write? So there is a little bit of a scientific way of figuring things out. We'll talk about that in a later class. So for now, I think that's all I have. So thank you for watching, and I'll see you next time.